Hi, my name's Carson, and I designed Bathymeter. I just wanted to make a quick video showing my assembly process. All of the modules are assembled by me here in Atlanta, Georgia. So this first step is basically the boards come from the PCB fab with these rails attached to the edge that they need for their assembly processes. So the first step is for me to snap those rails off. And then once I snap the rails off, there can be like a little bit of a jagged edge from the fiberglass. So I use a file to file that smooth and get any little like rough pieces of fiberglass off. And then I have these little 3D printed caddies that I use to hold the boards while they're in process. So then the next step is to add the LEDs. This is probably the part of the process I'm not fully happy with. I've been, like you saw earlier, the 3D printed caddies. I use a lot of 3D printed parts for my production process just to make things easier. So I'm thinking about making a 3D printed jig for this to like locate the LEDs properly, because you can see in this one sometimes they fall out and it can be a little bit janky. So I think I need to improve this process for the future, but this worked for the first batch. So once I place all the LEDs in through the holes, I solder them all. And sorry for my hat getting in the way there. As you can probably tell, I'm kind of new to making videos. So, yeah, so you just solder all of the LEDs in. And then once they're all soldered in, you snip the legs and toss them in the trash. And then I put them in my little caddy for the next step. And then the next step is adding the power connector. I use a footprint that I got from Winterbloom that helps hold the power connector in place, which is nice. The pins are a little bit offset, so I place that in and it holds it in place. And then I solder all of the pins of the power connector. And then once that's done, I also use this step to attach the standoff to the bottom. The top of the module, or the top of the faceplate, is held on by the nuts of the jacks and the potentiometer, but on the bottom, with the buttons and slider, there's nothing to attach them, so I have to add this little standoff here to keep the bottom of the module nice and secure. Then the next step is the biggest one, where we actually place all of the rest of the components. You can see that little blue jig I use. So for this step, I place all the components, and I generally place the components in order of which are least likely to fall out to which are most likely to fall out. Because like if the board gets bumped or something, I want the least, or basically the smallest amount of time that the board could get bumped and stuff would fall out. It's really small optimization, but I don't know. That's the fun of doing this. It's like pretend engineering optimization, right? So yeah, I place all the components in there, and then I put a little temporary front panel on, and then I place it in this jig. And what this jig does is keep all the buttons aligned in the same plane, because if there was nothing there, the buttons could kind of just like fall through, and they need to be aligned correctly. So that's what the jig is for. It also aligns the slider for the fader to be properly centered and everything. So then I just go through and solder all the points. My technique to soldering, I generally try to solder all of the pads of one component at a time to avoid missing any pads, because it could be kind of easy if you're just, going willy-nilly to miss a pad or two. So I generally try to do all the pads of one component and then move on to the next component. So in this case, you can see the headphone jacks at the top. Those are what I'm doing. And then once I finish the headphone jacks, I move on to the main potentiometer and then the slide pot and the buttons. And this is probably the most time-consuming part of the process. Been thinking about ways to improve this, but probably not with this module, maybe with the next one. And so once it's all soldered, electrically it's done. I just need to take this temporary front panel off. I use a temporary front panel because you get a little bit of spatter from the flux and the solder, and I don't want that getting on the final front panel. I want the final front panel to be nice and clean. So for this, I use a little temporary one. And then the final step is just attaching the front panel. So I pull out a front panel and, of course, have to look at it and inspect it to make sure there aren't any scratches or marks or mars or anything like that, because these are circuit boards, and circuit boards generally, circuit board manufacturers aren't the most concerned about aesthetics, whereas in this case aesthetics is important. So we actually got really lucky. There were only like maybe 1 or 2 panels with scratches on them. Usually it's a lot worse than that, but they did a really good job here. And so yeah, I basically just attach all of the screws and bolts and tighten them down. At first I just go finger tight, but then I've got some tools. Then once I attach all the nuts, I can put on the knobs, and then the module's done. And then the final step is to actually test the module to make sure everything is functional, because I don't want to accidentally send out a module with something broken on it. So I test every part of it electrically to make sure that everything works. So off screen, I have a clock, a generator, and a trigger output. I use a MIDI to CV thing, but it doesn't really matter what it is, just as long as it can output gates and a clock. So my first step is to plug in the first channel and go from the very bottom to the very top of the range and make sure the bottom is close to or a little bit below 0 volts and the top is close to or a little bit above 5 volts. As you can see, it's not perfectly precise. We're about 200 millivolts off on the top and or on the top and bottom, but Bathymeter isn't designed to be like a super duper precise module. It doesn't output volt per octave or anything like that. So then once I go through and test all of the channels output, I then test the speed knob, make sure the speed knob works, and give it a clock input and test the clock and the dub buttons to make sure they work. And then once that's done, the module is fully tested. So I do this testing for every single module to make sure every module is ready to go before it goes out the door. And then once it's done, I just pack the module up and it ships out to Mega Modular Corporation for fulfillment and distribution to the customers. So yeah, I hope you enjoyed that. That is how I build a bathymeter here in Atlanta, Georgia. Thanks a lot. Bye.